let's talk about the blackbody radiation. First things first, if you have an oscillating charged particles, that a charged particle that emits electromagnetic radiation. Okay, so when you have an oscillator, okay, when you have a particle that's oscillating, it can lose energy, but when that happens, okay, so let's say you got something that oscillates, okay, so it oscillates back and forth. So if it loses energy, basically what you're saying is it won't be able to stretch out as far as it would. Okay, so that loses energy, and the frequency of the light that is produced, okay, is equal to the frequency of the oscillation. Now, if your oscillator absorbs energy, so if you have an oscillator and light comes in, so it absorbs energy from light, then it can gain energy by being able, and as a result of that oscillator gaining energy, is able to stretch out further. Okay, so all objects then, since we're all made up of charged particles, protons, electrons, the nuclei of your atoms are positive, all objects produce electromagnetic radiation. So everyone right now is glowing. You are glowing. You are producing electromagnetic radiation. Okay? Now, a blackbody radiator is one that absorbs all radiation and re-radiates all of that energy. Okay? So the ideal case of a blackbody is one where you have a cavity inside a metal block. Now, if you want to observe what's happening, okay, so inside this block, you have radiation basically bouncing back and forth, okay, within the cavity. Now, if you want to observe the spectrum coming out of a black body, okay, you imagine you have a little tiny pinhole there. You take a peek, okay, and you look at the light that's inside that radiator. Okay, so it depends inside the cavity. It will depend on what the temperature of the object is, the spectrum. Okay, so how the intensity varies with for the different frequencies of light that you see, that you could find inside that cavity.